So we are going to start with our session 3. I would like to welcome our chairperson, Dr. Kumar Vishal sir. Welcome sir. Good afternoon. Dr. Kumar Vishal is working as an assistant professor in the Department of Mathematics, Magad University, Bodh Gaya. He has earned his PhD in mathematics from IIT, BHU. He has completed his master's from Banaras Hindu University. The central component of his research has been diffusion equation. Am I audible? Hello.
Ma'am, your bandwidth is low.
Yes, actually here Geo network, I am not able to start with my laptop. Yes, am I audible?
Yes, ma'am.
Yes, the central component of his research has been diffusion equation with fractional time derivative, which is the generalization of the so-called diffusion equation. He has also worked in the field of Chau's control, stability, and its synchronization for fractional order system. He has published 16 papers in the International Journal of Repute. With your permission, can we start, sir? Sir, Kumar Vishal, sir. With your permission, can we start?
Yes, ma'am, you can start.
Okay. So we would like to call our first presenter. His paper number is P26, Lakshmikant Umate, and its topic is paper number 26, SVEIR modeling for forecasting COVID-19 projection in India. Yes, Lakshmikant, are you ready? Lakshmikant?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Am I audible, ma'am? Hello.
Yes, Lakshmikant, you are audible. You can start your presentation.
Yeah. Yes. I'm sharing my slides.
Yes, share your slides.
Is it visible, ma'am?
Yes, it's visible. The presentation time is 10 minutes and question answer session is for 5 minutes. Okay.
Yeah. So, thank you so much for giving me such a wonderful opportunity to present my research work. And I welcome all the dignitaries for my presentation. My topic for the presentation is simulation of mathematical model for infectious epidemiological disease like COVID-19 futuristic approach. And my guide for the topic is Dr. Kanak Modi madam. She's an assistant professor, Department of Mathematics, Amity School of Applied Science, Amity University. I'm a research scholar for PhD statistics. So let's see what the topic has with the introduction. We all have facing with the COVID-19 scenario for past 2 years, and it has caused immense affecting scenario for COVID-19 over the health issues of us. And the situation of battling against it for every individual has a health concerns and need to have some measures that can be helpful for the fighting against the COVID-19. So mathematical modeling is always been a situation where we can find out the trends and possibility of how the epidemiological diseases can progress with. And there been a different model for epidemiological progression, epidemiological disease for its progression. In past, we've seen the mathematical modeling, SER model, deterministic model, and my research of area is to introduce a vaccination element in the SER model and derive the SER model into a SVAR model. So we have the different situation earlier on mathematical modeling for SER model with that is called as deterministic model before the vaccination phase, and after introducing the vaccination element, the SER model has derived into the SVAR model. So importance of this mathematical modeling, epidemic mathematical modeling as a
Lakshmikant. Lakshmikant. Message. Just a minute. I think there is a internet issue. In the meantime, he is again reconnecting. So we can start with the next presenter, that is P5. Experimental and simulation study, switching in RRAM. Yes, you can share your screen.
Yes,
Sikta
ma'am.
Kaushik.
Ma'am, Shikha
Yes.
Kaushik.
Yes, sir. You can share your screen.
Ma'am, my screen is visible. Hello,
Yes, it's visible.
ma'am. Am I audible?
Yes, you are audible.
Okay. Good afternoon to all present here. Myself, Shikha from Amity University, Noida, UP, is here to present my research work on the topic of experimental and simulation study, switching is RAM in International Conference on Advanced Materials in Innovative Technology. Now, first of all, that as we know, semiconductor memory is a basic part of the electronic frameworks. It is utilized in any apparatus that utilizes a processor, for example, PCs, advanced cells, tablets, amusement gadgets, worldwide placing frameworks, and so forth. In the previous 30 years, memories constituted 20% of the semiconductor industry, try to increase in the coming years. Volatile memories consist of static random access memory and dynamic random access memory, whereas flash electrically erasable programmable read-only memory is the leading profitable NVM invention. In view of their operating standards, memory gadgets can usually be
Ma'am, your
characterized.
voice is lagging.
Hello?
Your
Hello?
voice is lagging. Your voice is lagging.
Am I audible now? Hello?
Yes, you're audible.
Can I start?
Okay, continue. Continue, ma'am.
In view of their operating standards, memory gadgets can usually be characterized as volatile and non-volatile. So DRAM and flash are the latest prevailing memory advancements, both with the scaling problems. Nevertheless, the DRAM provides high endurance, flash consistency is minimal, and the process is delayed, and the program eradicate time is moderately high. So these characteristics may make RAM an attractive choice for the next generation non-volatile memory. Next, the outline of resistive RAM. Hickmost first revealed the resistive switching effect in 1962, which was seen by several observers over the years. So RAM is a two-terminal device where, as seen in the figure, an insulating layer is sandwiched between two conducting contacts at the bottom and the top of the film. So by applying the external bias across MIM, that is metal insulator metal, the resistance of RAM device can be altered. The electrode which is electrically grounded is called as bottom electrode, and the electrode on which a voltage or current is applied is called as a top electrode. So there are basically there are two switching modes, namely unipolar and bipolar. The switching mode which the switching direction is independent of the applied voltage polarity is a unipolar resistive mode. As compared to bipolar switching, mode switching occurs at high voltage amplitude. So the figure shows the schematic chart of working based on filament formation of RAM. So RAM is in low resistance state is changed to high resistance state by applying a reset voltage. RAM is changed from high resistance state to low resistance state by applying a fixed voltage during the forming process. Conducting paths form in the switching layer by applying a high voltage stress as a soft breakdown, and the RAM is shifted to a low resistance state. Now, first of all, I have taken the ITO coated glass, and a thin film of ZNO was deposited on ITO coated glass substrate with a thickness of 100 nanometer with the RF sputtering method as shown in the diagram. And the target was set at 7 centimeter away from the substrate, and the substrate was rotated at 10 RPM to produce a homogeneous deposition. And the process pressure was 8.1 into 10 to minus 3 mbar after adding argon gas to the base pressure. The radio frequency had a power of 100 watts. So our RM devices with ZNO layer has been observed to have traditional DRAM breakdown characteristics at extremely low voltage. After that, after deposition, I have done the characterization like AFM, atomic force microscopy, had been used to investigate the surface morphologies of the zinc oxide film. The topographic images are shown in the figure. The closely packed particles with a consistent size distribution were clearly apparent in the topographic images. The average size of zinc ZNO was found to be 19 plus minus 2 nanometer. The layer has a roughness of 35 nanometer as seen from the figure. And the nanoparticle size dispersion of deposited film is found to be 16 to 50 nanometer as seen in figure 3 SAM images. And with the surface morphologies creates lumps of micro and nano hierarchical structures that are equally dispersed. Furthermore, the RBS measurements has been done, Rutherford backscattering, and with the help of 5SDH2 tandem accelerator, which I have done in IUAC Delhi. In that, the thickness of ZNO film was determined to be 100 nanometer, as shown in the spectra. So according to here, I have used a similar simulation with that such a layer of thickness 100 nanometer, and the zinc atomic fractions were determined to be 55% of oxygen, 55% of zinc, and indium has 45% atomic fraction, tin has 0.05% atomic fraction, while oxygen having a 15% atomic fractions. After that, I have done the IV of this sample with the help of tungsten electrode, and I found the resistance ratio is been with the order of 10 to the power 5. As a well-defined hysteresis curve is clearly observed from this IV characteristics. And the same model I have designed through the COMSOL model. So in this, the metal electrodes, insulating layer, as well as the metallic filaments make up the ReRAM simulation model shapes. The thickness of the metal electrodes, which are 30 nanometer thick, varies different metal used in the simulation. Our active substance, which is really 100 nanometer thick, seems to be the insulating layer. And this insulating layer of our scenario corresponds to ZNO. And table 3, this listed the model parameters such as active layer and filament that were utilized there in the simulation. And there are physics and multi-physics used in this simulation. The ReRAM devices are simulated using two physics, but one multi-physics module. And the heat transport in solids and electric currents are some of the physics modules. So researchers are also employing electromagnetic heating to represent the effect of heating within those ReRAM devices as a result of the current flowing through them. So these are the modules which I have been used in the COMSOL model. With the help of these modules, I am able to design this model. So the parameters which utilize are that the low resistance state, that is known as on state, and high resistance state, that is known as off states, are represented more by these second and third columns. They have two options for modeling the metal connections. Secondly, there are, if I'll use top electrode like silver and the bottom electrode like gold. So this is known as asymmetric metal contact. And if I will use the same metals in both metal top and bottom, that are known as symmetrical metal contacts. And with the help of these things, model, I am able to validate my experimental results with the help of simulation. So this is that I have done, that we fit our experimental data towards the COMSOL model to verify my model. And two models representing the two distinct states of filament within the insulator are shown here. One is the on state and other is the off state. So metal connections and insulating layers are on model A and model B, that is shown in the figure. The filament is indeed the distance among the both. So this is the work done that I have done. That tungsten ZNO ITU ReRAM is built and simulated with the multi-physics simulation software in this study. The electrical and thermal characterization of ZNO-based RAM is the subject of this research, so such that an optimum structure may be developed either symmetrical or asymmetrical devices model and evaluated for IV characteristics, temperature distributions during the on and off state, that is low resistance state and the high resistance state. So for both constructed and simulated devices, IV vectors have been found. And at 2 volt, the resistance ratio here is found that is the 10 to the power 5. So that's all from my side.
Nice presentation. Yes, anyone can ask the question, if any.
Hello.
Hello.
Yes, Sikha. So
Yes,
as you are
yes, sir.
working in ReRAM, so
Yes, sir.
in your view, what are the challenges that you see in application of ReRAM in the current technology?
Sir, the challenges I've found to be more is the retention and endurance capability.
And in terms of cost also, whether
Cost also, sir, by if I'll use gold as a top contact, so the cost is very high. So instead of using these, I will be using like ITO glass substrate, like, and copper as a target, as an top contact. So yes, I'm finding the cost, this thing also as per your scenario.
and whether these ReRAM like materials are whether they are in market or not right now?
Yes, sir,
Or-
they are available. I
Okay.
used to about like I have 2 to 3 targets with me, like ZNO, ITO, zinc, all insulated targets that has been used in.
Like in our case, we use that pen drive or some flash memories where still they are using this technology or the old one.
Ma'am, sir, please repeat your question. I'm unable to get it.
Like we are using flash memories.
Oh yeah, yeah.
So in that case, whether they are using this material or still they are using the old one.
No, they are using the old ones, sir. We are working on that. We are facing some issues like scalability issues, like channel length. Nowadays, we are using, I think, below 12 nanometer. So the researchers have been working in this sites because it's very hard to understand the mechanism. Still, we are working on the mechanism, how its filament is working. Like there are 2 through 3 ECM and VCM, electrochemical, valence chemical. Like there are so many mechanisms. So researchers are working on that, understanding the mechanisms.
Okay. Thank you, Shikha, from my side. So if there is any other question.
Any query? So now we move to our next presenter, which is
Thank you.
Mamta. Yes, nice presentation. Yes, next presenter, P37, Mamta Gupta. You can share your slides.
Yes, ma'am. It's visible, ma'am.
Yes, it's visible.
Okay. Good afternoon, everyone. Myself, Mamta Gupta, research scholar, MIT School of Applied Science, Jaipur. Today, I am here to present my paper entitled Certain Generalized Fractional Calculus Formulas and Integral Transforms of PQ Extended to Hypergeometric Functions. In this paper, we have introduced to certain image formulas of the PQ extended to hypergeometric functions by employing Marchev-Saigo method, fractional integrations, and differentiation formulas. Further, certain integral transforms of the PQ extended to hypergeometric functions are established. All the results are presented in terms of the Hadamard product of the PQ extended to hypergeometric function and Fox-Wright functions. In this paper, first of all, we will cover the introduction part. In this part, with left and right sided generalized integral and derivatives transforms, define given equation 1.1, 1.2, 1.3, and 1.4. In recent years, extension of a number of well-known special functions have been investigated and studied. The PQ variant, in turn, when P equal Q, the P variant together with the set of related higher transcendental hypergeometric type special functions. In particular, Parmar et al. Introduced and studied the PQ extended to hypergeometric functions with under given conditions. Now by given equation 1.5, where b of xy pq is the pq extended beta functions introduced by Choi et al. In this equation, if p equal q equal 0, reduces four series in Vishnonkas to hypergeometric functions by given equations. Here, in our present investigation, we need the concept of the Hadamard product of two analytic functions. It can help us in decomposing a newly emerged functions into two non-functions. If in particular one of the power series defines an entire functions, then the Hadamard product series define an entire functions too. Let g of z and h of z be two given power series, then their Hadamard product to the power series defined by g dot h of z equal summation of n equal 0 to infinitive cn dn z to power n. These are Hadamard product functions. In this, in this paper, our aim is to study the compositions formulas of the generalized fractional integration and differential operators 1.1, 1.2, 1.3, and 1.4 involving PQ extended to hypergeometric functions. Corresponding assertion for the classical Riemann-Leibole and Erdős-Corbett fractional integral and differential operator are deduced, which are earlier obtained by Solanki et al. Further, certain integral transforms of the PQ extended tau hypergeometric functions are established, and all the results are represented in terms of the Hadamard product of the PQ extended tau hypergeometric functions and the Fox-Wright functions. Now, I'm going to discuss the results of our work. We begin the main results expositions with presenting a composition formulas of generalized fractional integral 1.1 and 1.2 and differential 1.3 and 1.4 involving Apple functions for the PQ extended to hypergeometric functions. To do this, we begin by giving the equations, the following image formulas asserted in lemma first and in lemma second without their proof. Now results are so in the form of various theorem. Now in theorem first. In this theorem, we have proved PQ extended to hypergeometric functions involving left-sided hypergeometric fractional integral operators in terms of the Hadamard product of the PQ extended to hypergeometric and Fox-Wright functions. Under the given conditions, we arrive at equation 2.5. And in theorem second, now results are so in the form of theorem second. Under the given condition, we arrive at equation 2.7. Similarly, results are so in the form of theorem third. Under the given conditions, we arrive at equation 2.9. And next result are so in the form of the theorem fourth. Under the given condition, we arrive at equation 2.11. Next results are so in the form, here are some theorems which show our results. In this section, first we give definitions of the certain integral transforms as beta, Laplace, and Whittaker transforms, and then we apply to the composition formulas for generalized fractional integral and differential operators like 3.1, 3.2, and 3.3. Using this definition of Euler-Beta transformation in theorem 1 to 4, and after simplification, we arrive the desired result asserted in theorem 5th, theorem 6th, theorem 7th, and theorem 8th. Similarly, using the definitions of Laplace transforms in theorem 1 to 4, and after simplifications, we arrive the desired result asserted in theorem 9, theorem 10, theorem 11, and theorem 12. And in, similarly, using the definitions of Whittaker transforms in theorem 1 to 4, and after simplification, we arrive the desired results asserted in theorem 13, 14, 15, and 16. Now, conclusion in this paper, we obtain certain image formulas of the PQ extended to hypergeometric functions by using Saigo's hypergeometric fractional calculus operators, and all the results are represented in terms of the Hadamard product of the PQ extended to hypergeometric functions and Fox-Wright functions. And here the references are 1 to 24. Thank you, sir.
Yes, nice presentation, Mamta. Any queries are welcome. Sir, any queries? Vishal sir, any queries?
No, ma'am. No query on my side.
Okay, shall we move with another presentation?
Yes, ma'am. We can.
Okay, fine. So as there was internet glitch with Lakshmikant, he has again joined us. So with the due permission of chairperson, can we start with Lakshmikant?
Yes, ma'am. You can.
Okay, okay. Thank you, sir. Thank you. Lakshmikant, you can share your slide. Lakshmikant, share your slide.
Yes, ma'am. Is it visible, ma'am?
Yes, it's visible. It's visible.
Yes. Sorry for the interruption. I quickly come to my topic: the simulation of mathematical model for infectious epidemiological disease, like COVID-19 for futuristic approach. Uh, as we are facing with many of the scenario from past 2 years for the COVID-19, and we need to battle it out for the health issues. So mathematical modeling always been helpful tools for battling out such a epidemiological diseases that has affected to the humankind. And in past also, it helps it helps over to see the simulation and the progression of the disease, how it impacts with the health system. So earlier there were the two deterministic models that been considered. The one is there were the two epidemiologic model that been considered. One is deterministic and another one is stochastics. The deterministic models that is mostly is used for the larger population. The stochastic model that is used for the larger smaller population or at a smaller region. So what we are considering for this research work, we are focusing on the vaccination compartment to introduce in a SIR model or say ACR model. The SIR model is the epidemiological model, is a basic compartmental model where the person first gets suspected and then becomes infected, and then after the infection it gets recovered. So at every compartment there will be a number of people that will be in there for their count. Earlier the basic model was the SIR model, the suspected, infected, and recovered model that we all know. And after the introduction of the term exposed, it has become the ACR model, where the suspected becomes the exposed one, and exposed gets into the infected compartment, and then after the infected, they get recovered. So this is how the mathematical modeling works, and this is how we can calculate the number of people at each phase with over the modeling. Now we in this research work, we would like to find out after the vaccination implementation or after getting the vaccination, how much the modeling turns out to be, and how much the people gets protected from this vaccination drive. So this model works for the number of population, how it brings out with the results by introducing the vaccination terms. So let's see what is the terms it defines. As S represent the number of susceptible individuals, I represent the number of infected individuals, and R represents the number of recovered individuals. With the fraction, we can find out the suspected individuals over the times with the population, and infected individuals over the times with the population, and recovered individuals over the times with the fraction of population. So what are the assumptions to start with for this model? We take it as a homogeneous model, where all the population we consider to be at a homogeneous characteristics, and we take it as birth and death rates to be the birth and death rates to be equivalent. We take it as a constant, and the rate of change in the size of ST for time t will be depending on the number of already infected population, amount of contact per day. We call it as a transmission rate between susceptible and infected population, and the number of already susceptible fraction of population ST in contact with the infected people. And K is the fraction fixed fraction recurs at every day depending on the average days of infection period disease have. So what are the equations that we finally bring out by this? We take it as the derivative equation first. ds by dt is equal to minus beta st by n into it. So this is the equation we take it for the susceptible population. With this equation, we can calculate the how much the susceptible population remain at the end of the course. So this is how the other equation works. For the recovery equation, we take it as dr by dt, and gamma is our the recovery rate. Infected population, we have dr by dt, and we have the equation beta st upon n it minus gamma into it. So this equation works on the derivative term. So finally, we get these three equations. With these three equations, we can calculate the whole number of samples. That is the basic componental model, SIR model we have for the first time. And then if we introduce the exposed term to it to find out the latency period, that is the period where the person gets exposed and the person gets into infected, means the scenario where the person gets exposed and then comes into the infected with the pathogenic transflow. So after introducing, the model becomes the SER model. This was the earlier work done up to this SER model. Now our research focus on the introduction of vaccination drive. So we calculated these other equations for introducing the vaccination term, and we come into the conclusion of finding with the results. Effective reproduction number comes as a 1.64. The flow rate, birth rate, we consider as a constant place, that is 67,000, near to 67,000. National mortality rate, we found out as 24,400 per day. The equilibrium population without disease we considered as 135 grams. The contact rate, that is a term we calculated over the model, and we found, coming into the conclusion that we calculated it with the 0.6063. So this is how the transmission is flowing at this pace. The vaccination coverage rate, average 18 lakhs per day. Vaccination efficacy, this efficacy we took it as on the secondary source of information because it is unethical to carry out the vaccination trial without any ethics permission. So we took it as a secondary source of information that is provided by all the companies over the vaccination product. The latency rate that we calculated as 0.92668. If you take the reciprocal of this, you will get the how much the persons are getting infected by this. The recovery rate, same thing. If you take the reciprocal of 0.096, you will get the how much the recovery is happening over the 1 day. This is induced mortality rate. We calculated as 746% died per day due to this humongous diseases. So how we calculated this result? We took the earlier R0, that is reproduction number, for the period 30 January 2020 to 30 June 2020. This was a period earlier where the COVID has emerged to the India. And for the next time where we introduce the vaccination component, we take the secondary data and we generated the results over on the secondary data. And we took this data from the different government organizational sites. And for the vaccination term, we took the data in the secondary phase from 1st of December to 31st of December 2022. So how we calculated this? We work it on the SAS programming software, where we firstly calculated the latency rate, and by finding the value of alpha, that is latency rate, we come into the conclusion of finding the other values of parameters. So these were the results I already discussed with. At the end of the scenario, we come into the conclusion that the reproduction number that was earlier has now been decreased. It was earlier, it was in excess of 2. Now it has come into the 1.64. So definitely vaccination is providing the benefits to the humankind against this disease. And why we took this as a reproduction number RT? Because earlier, when the vaccine was not there, we can consider it as a basic reproduction number. But after the vaccination, the scenario has changes. So now the reproduction number has to be re-evaluated, and we consider this as an effective reproduction number. With this effective reproduction number, once we calculate the effective reproduction number and the latency period, we can apply the formula for the modeling, and we can calculate the other parameters also. So these were our findings. So you can see the slides here. These are all the things we calculated as per the modeling. The only drawbacks this model has that we have to consider in the assumption that the birth rate and the death rate are equivalent. And over the scenario, this never happens, or may say this never been in a constant rate where the birth and the rate you will see as a constant one. So this is a drawback it has, but it is a slight drawback. It's not a big thing, but overall the model represents how the trends perhaps happens with any epidemiological disease over the scenario. And with this, how to reduce this spread, we have demonstrated how the epidemiological spread can be reduced. The transmissibility, if we took out the vaccination development, herd immunity, and wear the mask, the contact rate, if we can reduce this, we have to get the 6+ feet of physical distance, and we have to maintain the social distancing also. Duration of infection also we can implement, so we can reduce the flow of the transmission. So this is how our research work has worked out. And this is a bibliography of references. We took it from the other papers. And thank you for being attentive to my presentation. And I finishes my presentation with this. Hello.
Good presentation. Yes.
Yes, ma'am.
Lakshmikant, just show the slide of methodology. That yes, I want to see
Which slide, sir?
methodology that you have been using.
Methodology. Okay. Methodology. Yes. Is it visible, sir?
Yeah, it's visible.
Yes.
So that the secondary data that you have mentioned is, I think it is 1st December to 31st December 2022 or 21.
Oh, sorry, sir. It was 21. No, sir. We took it as I just elaborate this thing. Sir, we firstly we work it on the R0 basic reproduction rate. So our research work was carried out in 2 phases. The firstly we want to find out we would like to find out the reproduction number at earlier, that is basic reproduction rate. That is why we took it as a secondary data source of information, whatever the government has provided with, and we carried out for finding the basic reproduction number. And that is why we firstly in phase 1 we selected the time period 30 January 2020 to 30 June 2020. After the vaccination, we need to further progress on the SVAR model. So that is where we need to calculate the results, and that is where we took the data from the 1st of December to 31st of December 2021. It was my mistake that I mentioned it as 2022, but it was 2021.
Okay. Got it. And so that data you got from these 2 websites, and then basically that how did you do the simulation part? That I just
Yes,
wanted
sir.
to know.
Once we got the data here, we have to calculate some of the basic parameters that is needed for the derivative equations. So mainly the k values, that is the reciprocal of latency period, and also the reproduction number. So reproduction number we calculated by using the R software. There is a epidemiological session there where we can introduce our data and we can calculate the value of basic reproduction number and also the latency. After this after this value we move into the SAS software, and we just with the programming language we introduce our programming for the equations, and with the values that we have found out earlier one, we just put these values into that, and the rest of the parameters values were evaluated by the programming. So we just the initial one or two, that is two parameters that needed for the programming, and we actually generated the code over the programming, and the code was the simple one. The code where the we use for the SAS programming, the macro language, and the code were generated from the derivative equations. So that is the slide I presented earlier where the derivative equation was there, and with every parametric value we can find out the other parametric value also. So initially there were only two parametric values that were required, and we found out these values from the secondary data source of information.
Okay, so on the basis of your result, would you like to do any kind of forecasting? Because nowadays there are so many forecasting for fourth wave. So any kind of
yes, sir. Actually, yes, sir. Go ahead, sir. Please, sir.
So any kind of forecasting would you like to make on the basis of your result that you got?
Yes, sir. Yes, sir. Sir, this is a model that can be gone for any epidemiological disease. Now we are facing the situation with the COVID-19, but the fact that the SARS has already happened in 2002, and other influenza and other epidemiological diseases are always there in the cohort. So we can introduce this modeling even after the COVID situation can after get ended. For the next any epidemiological diseases. So we are not just as per our title, we are just focusing on the COVID-19 situation, but we can use it for the other epidemiological situation also. And this is my research topic that I am working on COVID-19 situation right now. But this is a mathematical model we can use for in any general situation over any epidemiological disease.
Okay, thank you, Lakshmikant, for your presentation.
Thank you so much, sir. Thank you so much, sir. Thank you, ma'am.
Yes, nice presentation. So you can remove your slides.
Yes, sir.
Now I would like to call upon Puka Zenthi P40 for her presentation. You can share your slides.
Vishnu.
Good evening to all of you. Am I audible?
Yes, you are audible. Your slides are not visible.
Right.
Yes. Yes, good.
Yes. So this work is actually a CFD analysis of pulsatile flow in elastic tube. Actually, we know that in actual blood vessels, the flow is not laminar or turbulent. Turbulency and laminar occurring at rare occasions, but in general, the flow is pulsated flow. And therefore, here we have attempted to have an CFD analysis for the blood vessels through some CFD models. Actually, the blood vessels also in our engineering side, we usually take the flow through a rigid pipes like that. Whereas in blood vessels, we have to consider the elastic nature of blood vessels due to the variation of pressure, blood pressure, as well as the nature of the blood vessels. Right. So we have tried to do some basic analysis. Right. So we have taken the arteries and cardiovascular channels for this concern. So the inviscous nature and pulsated flow are all considered. And the hoop stress, actually hoop stress we notice in solids with circumferential stress. So that factor also is taken into account here. Some related governing equations are given here. The relation with respect to axial variation. The axial direction here is taken for z-axis. The variation, pressure variation dou P by dou Z is given here. It is varying with respect to Reynolds number. That basic details we have taken into account. So here further relations for the axisymmetric case are noted here. Here actually the variation along the axial direction is not here, and momentum and circumferential cases are also not here. Only the axial variation is accounted here. And when we take into the account of hoop stress, we use that effect. That we know that sigma is given by PR by H, where P is the pressure and R is the radius of your blood vessels and H is the thickness in millimeter. Right. So here the parameters are given here. So we have taken a case where one tube, blood vessel tube is taken here. So the length is, unbranched length is 80 millimeter, and after branch we took 45 millimeter. The density is given as related to blood, then around 10,000 elements we have given with around 45,000 number of nodes. The velocity and pressure variations are noted. So we have taken into account the wall shear stress, then pulsated nature and the elastic nature. Instead of going through rigid wall assumption, we have taken elastic nature into account. And also, instead of laminar flow assumption, we have tried to make use of the equations related to pulsated flow. Actually, we have attended one NPTEL lecture where we have got the lecture was about cardiovascular fluid mechanics. So the equations and the related information we have tried to get from that NPTEL lecture. So some of the equations on the lesson what we have learned there we have used here, and we have attempted some basic results here. So the results we have attained that when we are including the pulsatile nature, the variation velocity is noted as 6%, and variation pressure is 25%. When comparing with the non-pulsatile nature, the results when we are going with the pulsatile nature is 6% in velocity profile and 25% in pressure variation, pressure profile. Just we have not done anything great. We have just modified the appropriate equations related to pulsated flow. So that's our one very simple work based on the lecture what we have attended in NPTEL. That's all, sir. That's all. Thank you.
Hello.
Hello.
That's all, sir.
All right. So that I'm not getting what do you want to conclude from your this work? So
Sir, actually here, what we would like to inform here is the blood vessels are analyzed through CFD solver. So here, instead of usual laminar flow assumption, we have considered the pulsatile flow equations. So the blood is actually exactly flowing in a pulsatile manner through arteries and other veins, etc., particularly near the heart. So the mathematical equations related to pulsatile flow, we have taken into account for the software, and we are getting some results which is differing from the laminar flow results.
so what are those
That's it.
results? What are those results? Would you like to elaborate?
Sir, that variation actually we have noted around 6%, sir. That say for example the shear stress and then for flow properties, they are also slightly varying, sir.
Okay. So it would be good if you could have put down those variations in your slide so that it is easily.
Yeah, sir. Yeah, sir. We just missed it, sir. Yes, sir. We will
Okay.
update, sir. Yes, sir. Yes, sure, sir. We will update, sir. Thank you, sir.
Do anyone have any query? Hello?
We
Can
should
we
move
move
to
to
the next
the next
presenter.
candidate?
Thank you, sir, and thank you, ma'am.
Can we move to the next presentation? Manvendra Narayan Mishra, please share your presentation.
Is it visible? Hello.
Hello?
Is it visible, ma'am?
Yes, it is visible.
Okay. Good afternoon to all present here. Myself Manvendra, and today my title of the paper is Analytic Solution for Oxygen Diffusion Problem Containing Local Fractional Derivative. So at first, going to the abstract, that what we have done in this paper, we have introduced a new methodology, that is local fractional homotopy perturbation along with the Smudo transform technique in oxygen diffusion modeling. This is the introductory part. The distribution of oxygen into absorbing tissues was the very firstly studied by John Crank and Professor R.S. Gupta. And when the oxygen is allowed to diffuse in the medium, some part of oxygen is absorbed by the medium, and that part is out of the remains out of the diffusion process. And this phase of the problem continues until a steady state is reached. And steady state means oxygen does not penetrate any further and it is sealed in the medium, so no oxygen passes in and passes out. Crank and Gupta also employed the uniform space grid moving with bound and necessary interpolation and many other methods. And after that, several methods have been employed to the problem, and some of them are Edelman decomposition method, homotopy perturbation method, and variational iteration method, homotopy analysis method, etc. And in this method, we have also introduced a new derivative, that is local fractional differential operator. And we have proposed local fractional homotopy perturbation in Smoother transform method to solve the local fractional model of oxygen diffusion. And after that, there are some prerequisites which we have used for the model, that is local fractional integral and local fractional derivative. There are the definitions of both the operators. And after that, we have taken the model of introduced by the Professor John Crank and Gupta. We have generalized the model which was given by the Professor Crank and Gupta. We have made it of fractional order, and then we have used the methodology which I have already mentioned. And this is all about the methodology what we have used. This is about Smoother transform and homotopy perturbation method, that Watungla at first developed this Smoother transform, and Professor Abhiyan Belgagan gives some important properties about the Smoother transform. After that, Belgagan investigated the applications of the Smoother transform to Bessel functions, and many other researchers have done remarkable work in the with the help of the Smoother transform method. And the SPSTM is investigated by Atangana et al. In solving space-time fractional equation. And similarly, Srivastava et al. Introduced the local fractional Smoother transform of a function which is defined as below. So this is the local fractional Smoother transform operator definition operator, and its inverse is given here. And now coming to our methodology, in order to establish the basic idea of local fractional homotopy perturbation with Smoother transform method, we have assumed the following differential equation with local fractional derivative LK, and where LK denotes the local fractional local linear fractional differential operator, and RK denotes the remaining linear operator, and H of xt is the source term. Now we have used the local Smoother transform method and find this equation, and after that we have applied the inverse local fractional Smoother transform method to get the following result. And then since we have applied local fractional Smoother transform method, and after that we have also applied homotopy perturbation method. Hello, is it audible or not? Hello.
Yes, it is audible.
Okay. So after that we have applied homotopy perturbation method, and homotopy perturbation method we have taken the solution in the series form and putting all the values in our previous result, and then comparing the like powers of t, we have got the values of the various constants P0, P1 and P2, and putting all these in the final solution which is given by this equation, we will get our final result. And after that we have taken an application about the same methodology and apply the same method with practical implementation, and we have done the same with some initial values, and we have got this result by using HPM. And same way we have compared the coefficient, and we found that P0 is 0.5 into 1 minus x whole square, and P1 is 2 into t to power alpha upon gamma alpha plus 1, and P2 and P3, and after that remaining all the terms became 0. And so our final solution is given by C of xt, where C is the concentration of the oxygen, and finally we have find the oxygen concentration in this form, and we have also represented this result in graphical solution. And here you can see that we have represent for various values of alpha the oxygen concentration level. And the conclusion of the paper is that we have proposed a new technique, that is local fractional homotopy perturbation Smoother transform method, to solve the local fractional model of oxygen diffusion equation pertaining to the local fractional derivative boundary value condition. We obtain the solution with non-differential differential terms by applying this approach. This result shows that the proposed technique is very efficient and can be used to solve various kinds of local fractional differential equations. Hence, the introduced method is powerful tool for solving local fractional and linear equations of physical importance. And these are the some references which I have used in my paper. Here I have mentioned some of, not all, only some of them. This is that is all from my side. Thank you.
Manvendra,
Yes, sir.
just show me the slide which is having the equation that you have
Which is
taken.
having- sorry, which is having the
Equations that that application part.
Yes, sir. Yes, sir.
Yes, yeah. Just wait. So see, this problem we can also solve by simply using the Laplace transform.
Yes, sir.
So what is the benefit of using your method?
Sir, actually, we have tried to done some unique thing with some new operator. We know that there are various transformation and various methods we can solve, but here we have applied two methods which are combined, and one is more local fractional Smoother transform, and second one is homotopy perturbation method. So we have applied both the methods combinedly, and then we have finally got our result and compared with the old one which were given by Dr. Crank and Dr. Gupta.
I think, see, in this case, because we can get the closed solution, so it is I think it could be better if you have taken some nonlinear problem, some this is a simple problem, and you have taken a method and you applied this method on a simple problem. I think it would be good if you have taken some complicated nonlinear problem, and in this case,
Surely noted, sir, and it will be improved in our next paper or next work.
and just show me the graph one, that
1 minute, sir. 1 minute.
graph.
1 minute.
So what are the conclusion that you get from these graphs?
Conclusion from these graphs are that with the time, the oxygen concentration level is decreasing gradually with the time. And these are also the findings of the paper of Professor Gupta.
Okay, thank you from my side. If there is any query, audience may ask.
So for today, all the presentations are done. So I would like to thank the Vishal sir for chairing the session. So with your permission, can we end the session?
Yes, ma'am. Thank you very much for giving me chance to chair a session. Yes, you can end the presentation.
Yes, sir. Yes, sir.